Hey guys, I'm here to complete the notes for section 8.1, should be 8.1 up there, for circles, arcs, and just basic vocab terms for circles. So we'll pick up where we left off with this utri number 4. Now, as I said earlier, before you try to go through and answer all the questions that they're asking here for these different arc measures, just focus on the picture and what you're given and try to fill in everything you can. So if I look closely at the picture, the first thing I notice is that we're given 100 here for this central angle, which automatically tells me that this arc, NM, is 100. Now, in addition to that, I notice that NP, this segment, is the diameter of the circle, which tells me that this is a straight angle. Therefore, if the left side is 100, the right side must be 80, which means that arc MP is going to be 80. Now, that only leaves me with one piece left. This arc up top, you could either call it arc NP or arc NRP if you want to use 3 letters, which is obviously going to be a semicircle, 180. So once you have all those measurements filled in your picture, now you can go back and try to answer the questions at hand. The first one they're asking about is arc NM. I already filled that one in. It's the same measure as the central angle, so it's going to be 100 degrees. Next one I'm looking at is MPN. So first I want to locate that on my circle. Now I'm going to take the short path from M to P and then continue in that direction to get to N. Now, it looks like in this case, I'm covering 80 and I'm covering 180. So I have to add those two pieces up, which together is going to give me 260. Next one I'm looking at is MNP. So now I'm going from M to N, shortest path, and then to P. All right, so that's going to be 100 plus 180, which is going to give me 280. And the last one, PM, which is the only arc I didn't cover in the last problem, which is just 80. For the next problem, I'm actually looking for a length of a given arc. So I want to know how long is this piece. So if I were to take this little arc and stretch it out, how long is it? Now I am told that the QN, this segment, is 4 centimeters. All right, and the other piece of information I'm given is this central angle, 75 degrees. Now, if you remember, to figure out the arc length, what you're going to need to know first is circumference. All right, well, to calculate circumference, it's going to be 2 pi times r. Okay, well, I was already given the radius right here, 4 centimeters. So know my circumference is going to equal 2 times pi times 4. Well, I'm going to combine these two terms, and I'm going to end up with a circumference of 8 pi. Now, once you get the circumference, now you can worry about finding the arc length. So to calculate the arc length, if you remember from our formula up above, it's going to be the measure of the central angle that opens up to that arc over 360 multiplied by the circumference. All right. Now, remember, when you're multiplying these two, put them both in fraction form. So it's going to be 75 over 360 times 8 over 1 pi. You're going to multiply straight across. 75 times 8, 360 times 1. Which gives me 600 over 360. And pi is still included. Now, the last thing I want to do is just try to reduce this. Obviously, these zeros are going to cancel out. And then I'm left with 60 over 36, and the greatest common factor between those two is 12. So I end up with 5 over 3 pi for my final answer. So now I'm actually going to go back to these examples that I skipped over earlier. In this case, they give you the circle on the right, and you're just trying to identify what part goes with what term that we learned earlier relating to circles. So first one I'm looking at is line GH. So let's figure out where that is on my circle. So it's right here. It's the entire line with both arrowheads. It intersects my circle at G and H. All right, now obviously it's not a center, so that one's out. A chord has endpoints on the circle, so that one's out. Same with the diameter, has endpoints on the circle and goes through the center. Radius goes from the center to anywhere on the circle. That's also a segment. So honestly, my only choice is secant. And I know it's going to be a secant because it intersects my circle twice. Okay, so now I can go back and fill that first one in. So I know that one's going to be E. Now for the next one, segment GH. So in this case, I'm only worried about going from G to H. All right, now we already ruled out secant. All right, can't be a radius because it doesn't touch the center, and it can't be a diameter because it doesn't touch the center. All right, and it's not just a single point, so it isn't the center, which leaves me with B. Next one I'm looking at is segment MJ. So we'll find that on my circle. It's going from M to J. Now, we already ruled out secant and chord. So in this case, MJ, since it's going from the center to a point on my circle, it has to be a radius. So for that next one, it's going to be D. For the next one, I'm just worried about a point, J. It's the point that's right in the middle of my circle, so therefore it must be the center of my circle. So I know that answer is going to be A. And for the last one, I'm looking at segment MH. I'm going from M to H all the way across my circle. Now my endpoints are on my circle, so technically that is a chord, but in this case it does go through the center of my circle, which is a special case, the diameter. So that last one is C. Now for this next example from the practice, first thing I'm trying to do is just find all the radii in my circle. So radii has to go from the center to any point on the circle. So it looks like all my answers are going to start with O. All right, so obviously O to D is going to be the first one. After that, you can go O to B. That would be the second one. After that, it can go O to M, would be the next one. And the last one would be O to Q. So that would be all my possible answers. And I would have the segment bar on top of all of them. All right. Next one I'm focused on is diameters. There's only one in this case. So the diameter has to go through the center, has to go straight across my circle. So the endpoints are on the circle. So in this case, it would be Q to B, and it's a segment. Next one I'm looking for is chords. There's two of them. Now, if you remember chords, they have endpoints on the circle. So it looks like in this case, we could say L to B. Those endpoints are on the circle. It's a segment. And we could also say, technically, Q to B is also a chord. Even though we listed that one up above for a diameter, it still falls under the definition of chord because the endpoints are on the circle. After that, I'm looking for a secant. Remember, we talked about this one earlier. There's only one of them in this picture. Has to be a line, so it has to be one of these lines in my picture, and the important thing about a secant is that it cuts through your circle twice. So in this case, this line cuts through a point L and at point B, so I'd call it LB. But the difference from the one up above is that this one is a line with arrowheads. Next one, now I'm looking for a couple tangents. All right, as I said before, a tangent only touches your circle at one single point. So it looks like this line that touches my circle at one point. So you have a couple options. You could call it PC, you could call it PL, you could call it LC. Just make sure you include the arrowheads. And then this one down below, where it only touches my circle at point Q. In this case, you could only call it TQ or QT. Next one, now you're just looking for a minor arc. Remember, a minor arc is less than a semicircle. All right, so you just want to make sure it's not going halfway around your circle. So, for example, I could say B to D. And then make sure you use that little arc symbol up above, that little curve. Now, for the next example, I'm looking for a major arc. Well, I just identified a minor arc, so the major arc would be more than halfway. So you could say everything I didn't highlight. So that would be all this in blue around my circle. Now you have to name it. You're going to have to use 3 letters to name it. All right, so I can say B, Q, D. All right, and I'm going to use that arc up top. So this tells me that I'm going from B to Q, the semicircle, and then from Q to D the rest of the way. And the last one, you want a semicircle. Semicircle is just halfway around. So instead of going from B to D, we can go from B to Q. If you want, you could use 3 letters to name it, but we really don't have to. B to Q is understood. So for this next example, you're looking for a bunch of different arc measures. As I said, just focus on the picture, the very blurry picture, and what's given. I know the center angle is 151. So immediately I know that the arc that it opens up to, arc JI, is also going to be 151. Now, I also noticed that JH is a diameter. So that tells me that this right here is a straight angle. So if the left side is 151, then this right side has to be 29, which makes this arc 29. Next thing they give me, right angle right here, which means this arc is 90. Now, once again, this is a straight angle, so that means that if the left side is 90, the right side is 90. Once all my measurements are labeled in my picture, I can go back and try to answer some of these questions. First one I'm looking for is G to J. We already labeled that one. I know that arc measure is going to be 90 degrees. Next one I'm focused on is G to I. So this one's a little bit bigger. It includes G to H, which is 90, and it includes H to I, which is 29, which gives me 119 total. Next question has me looking at arc GJI. So I'm going from G to J, which is going to be 90, and then from J to I, which is going to be 151. Add those two up, gives me 241. Last one, I'm focused on GIH. So I'm focused on G. Now, the short path to I would lead me this direction. But then for me to get to H, I'm going to have to come all the way around and overlap that GH section. So instead, what I'm going to do, because I don't want to overlap, is I'm going to take the long route to go from G to I. And then I'm going to go from I to H. Now, in this case, I'm almost covering the entire circle. This is definitely a major arc. So what I'm going to do instead is do 360 minus, and I'm going to take out this one arc that I'm not using, 90, which leaves me with 270. For the next couple, I'm looking for arc length, and I'm keeping it in terms of pi. Well, don't forget about your formula from earlier. Arc length is going to equal the central angle over 360 times the circumference, whatever that is. So let's get started. For the first problem, in my equation, I'm going to start with the arc, which I know is 120 over 360, and I'm going to multiply it by the circumference. Well, remember, circumference is actually 2 pi r. In this case, it looks like the radius is 9. So I'm going to do 2 times pi times 9. First thing I'm going to do is I'm going to clean up my circumference a little bit. So instead of 2 pi r, I'm going to multiply these two terms, which is going to give me 18 pi. And that's still being multiplied by 120 over 360. Now, if you want to, you could reduce this fraction right now to make it a little bit easier. So 120 over 360, we can get rid of those zeros. 12 over 360, I can divide both of them by 12 actually, which gives me 1 over 3 times 18 pi. Now remember, when you're multiplying these fractions, technically it's 18 over 1. I'm just going to multiply straight across. So I'm going to have 18 times 1, which gives me 18, 3 times 1, which gives me 3, and I have pi. But I can reduce that to 6 pi. Now, for the next problem, 14, they don't give me my central arc directly. So I'm looking for the measure of that, or the length of that arc right there in blue. Now, what they do tell me is this over here on the right is 30. Well, obviously I can tell that this is a semicircle because of the diameter here. So the whole thing's 180, which means that if I do 180 minus 30, it's going to leave me with 150 for this arc. So I'm going to use that in my equation. So my central angle is 150 over 360 times the circumference. So I have my equation up here for that. It's going to be 2 times pi times r. Well, in this case, my radius is actually 9. I'm going to end up doubling it anyway, which is actually just going to give me 18 again. So I end up with 18 pi times, and we'll reduce this while we're at it. So I can cross out both those zeros, and then 15 over 36. I can divide them both by 3, which is going to give me 5 over 12. Once again, I'm multiplying these together. You can multiply your fractions straight across. So I end up with 5 times 18, which actually gives me 90, over 12 times 1, which gives me 12. I still have pi on the end. And the last thing I want to do is just try to reduce this. And I can divide both of these by 6, which is going to leave me with 15 over 2 pi. Or technically you could change it to a decimal and say 7.5 pi. Now, for the last one, they give us our radius directly, and they give us this arc measure. So I know this little piece that I really don't care about at all. What I'm looking for is this arc, all the way around except for that 45. So what I'm going to do is 360 minus that one piece that I don't care about, which is going to leave me with 315. So when I set up my equation, I know my central angle is going to be 315, so that's this angle right here, over 360 times 2 pi, and then my r, which is 20. So once again, I'll multiply these two together, which gives me 40 pi, and before I move on, I'll try to reduce these as much as I can. And I can divide both of them by 45, which gives me 7 over 8. But then, once again, remember, I still have to multiply these. So I'm multiplying straight across with my fractions. 7 times 40, which is going to give me 280. 8 times 1, 8 pi. Last thing I want to do is reduce this. And it goes in evenly. 280 divided by 8 leaves me with 35